8 o'clock. So I guess we can go ahead and get started. We've got a good amount of people that have joined in. Let me do some starter stuff for people that are just joining in, and then I'll hand it over to Daniele for the presentation and the workshop. So the blog's up. If you want to follow along and check all this out, the blog is in the chat. I believe everyone can see it. If you can't see it, let me know, and I'll post it again. If you have questions, ask questions in Q&A, and we'll cover it at the end during QA. We're not going to do it live while things are happening, but we will answer it at the end. There's going to be plenty of time for the QA stuff. We just want to make sure that we get through all the content, and then we'll go there. So if you think of something, post it in there, and then we will get to it. Oh, is the chat? All right, so we had a question already in the Q&A. Is the chat meant to be disabled? I think maybe I don't know if it's disabled, and maybe we're just doing Q&A so that we can answer there, so it doesn't get overloaded with being able to post the blog posts or other things that we need to post that are resources. But I'll see about that as soon as we start presenting. Also, you can join our Slack if you want to ask questions too. So slack.loft.sh and go into the vCluster channel. And if you have questions, we'll be watching for questions in there too. I think Daniele said that they're in there looking for questions too, just in case. But all right, let me go ahead and introduce. So I didn't introduce myself. Mike Peterson. I'm with Loft Labs Technical Marketing, and I'm here with Daniele from Learn K8. So you've been doing a lot of Learn K8 stuff and like teaching on Kubernetes and teaching the community how to use things, right? Like this is going to be a single cluster versus each their own, right? This is the first question I think you see as soon as you get into Kubernetes. Does everybody get their own? But I'll hand it over to you, Daniele. It's nice to meet you, and I can't wait to hear your presentation.
Yeah, thank you very much for the intro, Mike. Appreciate it. So yeah, I think one of the first questions that everyone asks is, I've got these clusters. Should I create more? And how many more? And I think the questions, it sort of seems simple at the beginning, but as you explore the topic, at least what I did for this, what I researched for this this presentation, I found that there is so much variety, and then the variety has changed quite a lot if you look, throughout the years as well. And that takes me to today. So, before I start, let's just see a few words. I'm like Mike said, I'm Daniele, so I'm one of the instructors at Learn Kubernetes, and I spent quite a lot of time working with Kubernetes, so much time that my colleague Chris called me D5E. I was lucky enough to present at KubeCon twice, and I was one of the first 500 engineers who got the CKA certification back in 2017. That was when the exam was 3 hours long and not just 2 hours. So yeah, that's how long I've been doing this. And today I want to talk about multi-tenancy. In particular, when we're talking about multi-tenancy, I think my research has been around three sort of categories, three areas. The first one is isolation. So when I look at multi-tenancy, the kind of questions that I ask myself is, okay, do I trust the people that I'm onboarding in this cluster? And what is the kind of level of trust? Do I trust them because they are in the same, they work in the same company as me? So I can go and say hello. Can I go to their desk and say hello? Am I onboarding tenants that I don't necessarily know? So maybe they are external. So there is a team external working with my company, and I need to provide them an environment for them to play with. Or I'm writing third-party applications and I don't trust them at all. So I think, there are different sort of levels of trusts when it comes to isolation. And then the other things that are sort of explored is, okay, if there are different levels of isolations, what is the cost? What is the cost involved in maintaining these different levels of isolations? How much does it cost to actually build this platform, but also operate it, and the effort and knowledge and the manpower that it takes to run such thing? And all of these sort of things then they come down to, how much cost and how much time do I need to invest in building and maintaining this platform? So this was basically, sort of the question that I had. And then, so I started investigating and sort of mapping out what I think are the three different scenarios that sort of depict how we can look at this multi-tenancy in Kubernetes. Now, before we talk about multi-tenancy, I just want to do a quick recap on how we deploy and we create Kubernetes clusters. And this is because we just need to put things into context before we actually dive into multi-tenancy. So generally what we have is collection of servers, and in the collection of servers, what we do is we have one of these as a control plane, and the rest of the fleet joining as worker nodes. And once we join these worker nodes, then we have what we call the cluster. So from a perspective of a user, then when we deploy workloads, we deploy them in the cluster. There is no node as such. But in reality, what we have is Kubernetes just looking at these workloads and placing them in different nodes inside the cluster. This is probably not news to you. And probably what is not news to you is, sometimes we also find a way to sort of make sense of all these deployments. We want to group them in a way that is easier for us to manage. And that basically for that reason, we usually use something like namespaces. And namespaces are basically just a grouping of things. And most of the time, we also think about, namespaces is taking a slice of this cluster and just partitioning it so we can use it for different teams. And this is basically where things become a little bit more complex, right? So namespaces, in essence, they lead us to think that, okay, this namespace is for this team and this other namespace is for the other team. So we do sort of a mental mapping where we map a tenant to a namespace, which is, I guess, okay. But you can also see that sometimes namespaces are associated with projects. So project A in namespace A, project B in namespace B, and so on and so forth. So is really a namespace a tenant? Well, it's a little bit tricky. And to explain what is tricky, I want to show you something. So let's say I've got an e-commerce website. And an e-commerce website, I've got a team A, who looks after the checkout. So they create the deployment. They've got some network policies, limit range, resource quota, and so on and so forth. And then team A is doing very well, and it gets assigned a second project. And the second project is basically just the user accounts. So where the user can go in and change the details, the billing details, and so on and so forth. Now, team A might create a second namespace, and that second namespace could contain another deployment. And then it might also contain the same sort of resources, such as limit range, resource quota, but also roles, right, and permissions as the previous project. So this team is basically managing two namespaces because there are two different projects in there. And the reason is, and they could potentially merge everything into a single namespace, but that would be problematic if they need to migrate. So here's the problem. So we've got two namespaces, they need to duplicate resources. They don't really want to merge into one because otherwise it's becoming more complex to manage exceptions. We really see how there is some sort of tensions about these namespaces being sort of a flat structure that groups the resources. So what can we do? Well, there is one project from SeaGolf, which is quite interesting. It's called hierarchical namespaces. And what this controller lets you do is basically lets you just nest namespaces. And with nested namespaces, what you can create is a namespace for the entire team, and then a child namespace for each project. But the beauty of this controller is basically that once you create these child namespaces, then those child namespaces will basically, those namespaces will basically just inherit any sort of resources that you want from the parent namespace. In this particular case, imagine that I've got a purple limit range, a yellow resource quota. As I create them in the root namespace, those are basically copied. They are basically propagated inside the children. And if I create, let's say, a network policy, and I enable the propagation, and I create a child from a nested child, then those three resources will be propagated as well. Okay, so in essence, what we have is we have Kubernetes namespaces, but this namespace controller, what it does, it gives us some sort of extra layer where we can organize our resources more precisely, right, and without duplicating them. And what does it look like when you actually use it? You basically install this controller, which is a component that lives in the cluster. And then you've got a kubectl plugin, which enables you to do this kind of commands, where you can create a relationship between two namespaces. So in this particular case, what I've done is I've created a role in the parent namespace, and then as I create child namespaces, then a child namespace, that child namespace will inherit that particular role. Which is great. So I don't have to duplicate things. I can just inherit them from the parent namespace. This is a good workaround, but there are some sort of edge cases. And the edge cases are basically, this works. I mean, namespaces work because we can namespace resources, but not all resources in Kubernetes can be namespaced. So take for example, a persistent volume. Persistent volume is a global resource in Kubernetes. So if you look at the API, so all these deployments and pods are basically just API in Kubernetes. If you look at those, things such as pods have got a namespace, but a persistent volume doesn't have a namespace at all. It's just like a resource which is available to the entire cluster. And other examples are namespaces themselves, or nodes, or validation webhooks for admission controllers. And those, basically those resources are stored inside etcd. But what happens when you want to grant access to these resources? Well, if I grant access for read and write to team A, team B, and team C, they will all be able to see this persistent volume, right? Which is sometimes something that I don't want, right? I want to have this team to have a single view of the cluster, which is just their own resources. So we're already seeing that how Kubernetes is basically giving us some levels of isolations, but it's sort of bending the rules on others. So on isolation, this is probably okay if you're working with, colleagues and teams within your company. This level of isolation is probably okay. But perhaps, you're looking at this and say, well, this is not really my cup of tea. I want something a little bit more, right? Before we move to something a little bit more complex, I just want to touch on something related, which is upgrades. So we talked about, how multi-tenancy, we're going to measure multi-tenancy on three different sort of axes. We're going to look at isolation, ease of management, and costs. So one interesting thing to look at is upgrades. So this applies to namespaces and the controller we just presented. So back in Kubernetes 1.18, I think, we used to have this very old, we used to have this definition of the ingress, which was the V1 beta 1. And then sometimes I think in 1.19, it was upgraded to V1. And one of the interesting things is that this process of upgrading and removing APIs in Kubernetes is quite common, right? As things move and as the resources mature, then some of the versions are deprecated. The challenge is that sometimes these deprecations are problematic. And the problem came at the time, we had a problem where all of these V1 beta definition for ingress were basically removed in Kubernetes 1.22, but it was still working in 1.21. And this is exactly a good scenario to explore how dependencies in multi-tenant clusters are problematic. So what happens when you have several teams in your clusters all sharing namespaces, right? And one of those teams developed the app and then just abandoned it. I mean, it's still maintaining it, maybe. It's just in, it's sort of in a maintaining phase. It's not actively being developed on. If this team is using an ingress V1 beta, then this cluster will not be able to be upgraded, because at the time where we do upgrade it, then their resources will go out of sync with their repo, and there might be issue with the ingress. But if there is no budget, who's going to upgrade this resource? I mean, this is basically where we are sharing the same resources, so we need to play nicely. We all need to be playing nicely with what we've got. The right thing to do will be to update the ingress, but that's not always possible. So overall, just using namespaces or something a little bit more than namespaces, like hierarchical controller, is okay. You get isolation, which is fairly weak, but it's okay. It's generally just cheap, but you need to be able to go out and interact with teams and just make sure that you move all of your tenants and help them progress through their journey with your cluster. But the real issue is that you're sharing pretty much everything in the cluster. So namespaces are something fundamentals in Kubernetes. You're sharing the control plane. And sharing the control plane basically means that whatever resource you create, like the ingress, is created in the same database as everyone else. And that's okay, but you need to be able to manage it. And the second sort of challenge that you get with this is that if something goes wrong with the API server, it's still a shared resource. So it doesn't just apply to resources, but also components of Kubernetes. So if someone abusing of the API server and the API server restrict the number of API calls, this is basically going to make the API server unavailable for everyone. So not great isolation. So what can we do to actually isolate this problem? And here's a clever solution. So what you could do, instead of having a control plane, you could basically create a control plane as a pod, as a regular pod. And instead of issuing commands directly to the control, to the cluster, then all these commands are sent to this control plane, which is running as a pod. And this control plane has no node, okay? But this control plane has got the same components as a regular Kubernetes cluster. So if you create a pod, then that pod will be stored inside etcd or any other sort of store that you have. Unfortunately, there are no nodes, so this pod is not created. So how can we fix that? Well, what if you actually copied that pod from one control plane to the other, right? I think that would be enough. The second control plane has got nodes, so I could actually deploy that pod inside the infrastructure. And that's basically the idea behind vCluster. So vCluster is basically just a very convenient way for copy some of the resources inside one control plane inside the host cluster. And this solves some of the problems that we've seen before. And I think this is where things get a little bit more interesting. So if, let's say we talked about persistent volumes as global resources. So you can create the persistent volumes inside one of these nested control plane, right? And then what will happen next is the vCluster controller would basically copy this resource. So you can think about this YAML file that you store inside the control plane. It's going to be copied inside the host control plane. And then that's basically when the persistent volume will be created. So in essence, we're using this nested control plane just as a way to manage resources inside the database. And when we're ready, we basically copy these resources across to the real cluster. But the advantages of this is that all of the resources that are being created are basically created inside this nested cluster. So you get good isolation. So if I go back and I list the persistent volumes, then I will be able to see just the persistent volumes in this tenant. There is no way that I can see all the persistent volumes, even if all the persistent volumes are just global objects. So overall, isolation is just like so much better than just plain regular namespaces. However, there is something to keep in mind here. So if we look at the same example of upgrades that we discussed with ingress controllers, let's see how that plays out with a nested controller with vCluster. So with vCluster, so imagine that you've got the nested cluster on 121 and the host cluster is 121 as well, so same version. If you have an ingress, which is in VB201, then the sync will work. However, if you upgrade if you create the main cluster and the tenant is still an old version, then what happens next? Well, in 122, we are not able to read V1 beta, right? So this is taken straight from vCluster documentation. So you basically need to go, what is this saying? It is saying that basically you need to disable sync and upgrade the tenant, right? Because you're not able to sync because this control plane doesn't understand that resource anymore. Now, these highlight some of the constraints that we're playing with, because yes, vCluster is giving us a full control plane, but the syncing mechanism carries some extra complexity when it comes to management, right? So we are trading this isolation for ease of management. Now, let's have a look at something else. What if I overload the API server? Well, that's okay. It's just going to break one pod, right? And that tenant is going to be isolated. So overall, this is giving us more isolations than we had before. However, the node is still shared. And what I mean by shared is that, all the pods that are deployed on that particular node then will have the same kubelet. And the kubelet is that agent lives on the control plane, which just pulls down information from the control plane and says, okay, let's create this pod. And to create the pod, it goes through 3 steps. It goes through a container runtime interface, the container network interface, and the container storage interface. But these pods are basically just containers, and containers don't actually exist. They're just basically processes with extra constraints, and constraints comes in the form of you're not allowed to use more than this memory, or you're only allowed to use this amount of bandwidth. And they also have things such as namespaces, which lets you isolate what kind of network they have. But bottom line is they're just processes. So you could have someone escaping this container and gaining access to the node and be able to see all the other pods inside that node, or a single kernel crash could take down the entire node. So this could be problematic for, because it's going to affect other tenants as well. And then the other things to keep in mind is that Kubernetes has got 2 fundamentals rule for networking, which is any pod can talk to any pod. So even if you have these tenants control planes, then the pods deployed inside the host cluster, they can still talk to each other if you know the IP address. And that for some, maybe depending on the type of industry you work in, might be something to keep in mind. It depends what you do. Just something I guess, to keep in mind. So how can you avoid this problem, right? What if you're going to have more isolation? What if you don't want to share nodes? You can have node pools. What if you want to have more restricted networking? What kind of options do you have? Well, you can try and keep to harden sort of this configuration, or you could go to the extreme, and the extreme is having a dedicated cluster per team. With a dedicated cluster per team, then each team has got their own cluster. And if that sounds overkill, then you haven't heard of Kamada. And Kamada, the way it works is basically one of those tools that you basically install on what we call a management cluster, and it's got sort of its own control plane, which sits on top of the Kubernetes control plane. And what it lets you do is basically lets you control other Kubernetes clusters. And why would you do that? Well, maybe because you want to have a unified view of everything that is deployed across all the tenants, or maybe because you want to deploy a pod on all the clusters that you maintain. So in this particular case, what Kamada does is they connect with an agent to the cluster, and they can interact, and then they can interact with the API server. So with a single kubectl apply, I can deploy a single pod in all clusters, or I can have like policies on how this pod is going to be deployed. But the team, they've got access to the local cluster, so they can still interact with it, and they can still create their own resources. What's interesting about this is that you've got a management cluster, right? Which is, I think the way I like to think about this is that it's very similar to what I see with vCluster, but it's taken to a next level by having dedicated cluster. So I still have like something central to check what's going on, but then I just delegate all of these, creating pods and deployments to the other clusters. And I can have the manager pushing a pod, which is common to all, or I can have clusters deploying individual pods and their own pods inside the infrastructure. And I can take these to extreme, and I can also have these clusters located in different locations if I want to. Why not? And this is kind of very much an extreme, but I could control the pods being deployed there as well. Now, as we did for the previous 2 tools, if you look at upgrades, they sort of look simpler, because what you do is basically you need to find a way to upgrade a cluster, and that could be like creating a second cluster and then replacing it. But I think this is sort of very naive. I think upgrading clusters is never such a easy task. So I think this is probably a little bit more complicated than it seems. And what about blast radius, right? We had a look at the other options. What if something goes wrong? What if we lose the control plane? What if we lose the API server? What happens next? Well, in this particular case, then the failure will be isolated to the cluster. So if team B has got a problem and they take down the wrong cluster, then it's isolated to the wrong cluster. That's it. If the manager cluster goes down, yeah, not a problem. The other clusters can still work. We won't be able to see what's going on, and we won't be able to push any other pods. But at the very least, all the other things are independent. So not too bad. So isolation-wise, this is great, right? But when it comes to ease of management, I mean, we are talking about managing clusters at scale, which is okay if you have something like Commander where you can push the deployments, but what about all the rest? How are you going to self-serve these clusters? How are you going to maintain the updates? How are you going to keep them up to date? How are you going to manage them? So I think there is a lot of choice and a lot of things you need to think about when it comes to adopting something like this. And let's be serious. I mean, we are comparing here. We have dedicated clusters. So yes, you get good isolations, but the trade-off you have to pay is quite high. And cost is something that I haven't talked about, but I think it's something that we should be talking about. So I presented you 3 options. So the hierarchical controller, vCluster, Kamada. And if I were to look at those, then I could almost picture them and say, okay, I've got a baseline level, which is Kubernetes, namespaces. Then installing and managing something like the hierarchical controller. Okay, it's good. It's giving me some isolation, weak probably, but overall it's basically giving me some flexibility in organizing my resources and propagating them. And the cost is not particularly high. I just need to run a controller inside my cluster. So overall, okay. And then we look at vCluster. In vCluster, the cost is, okay, I'm running a cluster. And on top of that, I need 1 control plane per tenant and a controller which is going to do the sync as well. Okay, this is probably manageable, but the more tenants I have, the more control planes I need to run. So I think the cost-wise, still manageable, but it's definitely not as cheap as running namespaces. And then you have the extreme, which is basically running one entire cluster per team, right, or per tenant. And that's basically, the cost comes from running these separate control planes, as well as extra nodes, as well as the ability to not be able to share resources. Everything is dedicated to that team. So the cost is quite high. But I think, when looking at costs, we just look at those, most of the time, at least doing my research, I was just looking at a cost and say, okay, is this the end of the story? And then this is basically when I got sort of sidetracked. So at KubeFM, so we launched a podcast about Kubernetes, and then there is one question that we ask all guests, which is, what are the 3 tools that you'd install in a brand new cluster? And then we've run about 20 episodes so far. So it's a very young podcast, but the kind of answers that we get about these questions are very, very consistent. So it seems like the 4 top tools that are mentioned in the podcast are Prometheus, External DNS, Cert Manager, and Argo CD. And this got me thinking. Let's take Prometheus, right? When you have a multi-tenant cluster, what do? Do you have one single Prometheus, or shared across all tenants, or do you have like one Prometheus stack per tenant? Right. I think the answer, of course, is it depends, right? But yes, it depends. But it depends, it actually adds up into costs. But the costs are not added linearly, because if you think I want a single Prometheus because this is going to help me manage the costs, I would say, yes, you're right. But what about in the case of Kamada? You can't really go with single Prometheus. Even if you install something like Thanos, you need to have one Prometheus per cluster. So the costs don't necessarily scale linearly with all of the options that you have. And on top of that, you could go multiple Prometheus where you have one Prometheus per tenant, and that will be, a fair chunk of costs that you're going to add on. But what you're going to do with it, you're probably going to have something like, which is going to centralize the metric as well, which is going to be something else that you need to build, deploy, and maintain somewhere else, which is going to add more costs. And if you think about it, this is just metrics with Prometheus. What about logs? Maybe with logs, you do the same, right? You have some logs per tenant, and then you aggregate them. So you keep adding costs as you go down. So, and it doesn't scale linearly either. So what you end up with is that there are some costs which are direct. So you count the number of nodes, you count the number of control planes, and there are some costs that are sort of consequences of what you decide, right? Like Prometheus. Okay, now I need to install one Prometheus per cluster because I chose Kermada. And this takes me to sort of the end of the presentation, at least, sort of this summarizes how I basically came about to think about all of these different options that we have in multi-tenancy. By the way, I present 3 options, but reality is that in the community, there are more tools, and sometimes they overlap, sometimes there are some gaps. But basically, this is generally, how I see them now. I spent some time researching them. So generally, I would basically divide them in 2 blocks. The first one is a single cluster, right? I want to have everything self-contained in a single cluster. And the second part is basically dedicated clusters. And in single cluster, I basically have 2 options. And the option is, okay, do I want to keep a very light version of multi-tenancy? Or do I want to go and have like a little bit more isolation? And if I want to have a little bit more isolation, I need something like a dedicated control plane for me. And on top of those, I basically have what I call add-ons. So add-ons are basically a way for me to restrict even further, to isolate even further my tenant. They will cost me some money or some effort, but it will basically give me more guarantees around isolation. And then on top of that, I basically have got, what should I do with monitoring and logging? And, also, what should I do with other shared resources, like Ingress, for example? Right? I can always go for, should I have a single resource for everyone and share? Or should I have a dedicated one and then move on? And then we can play with this and see where we go, right? So let's say that my multi-tenancy is mostly deploying. So I've got a few tenants. Let's say I've got 4 or 5 tenants, and they mostly deploy web applications. And those web applications tend to be static web applications. So if I think about it, then my choice would be, should I go with something like a dedicated cluster? Probably overkill. Okay. So I'm left with, okay, single cluster. And then single cluster, do I need a shared control plane, or do I want a dedicated control plane? I mean, in this particular case, these applications are basically static websites. So I want to go cheap. I want to go very lightweight. So maybe a shared control plane is fine for me. Do I need any dedicated node pool or a sandbox runtime? Probably not, right? Maybe I can go with the sandbox runtime if I think that the app could be exploited, maybe. Or I can find other solutions to sort of harden these containers. And then I'm left with the choice of what kind of monitoring or logging I want. Maybe I want to go shared. Maybe I want to have like a dedicated ingress because I'm concerned that one of these apps will actually need more, different parameters. Like, for example, a very common reason to have dedicated ingress control is that when you're uploading files, then you need to configure your reverse proxy to actually accept that, 50, 10, 20, 30 megabytes of upload. But not everyone might want the same upload size. So you want to be conservative. So if you want to do that, then you need a dedicated ingress controller. Let's have a look at another one. So let's say we have a CRUD application with a database. Right? How is this going to change when I think about multi-tenancy? Let's say I've got, the same 4 or 5 teams, but instead this time they've got a database like in Postgres, and they've got, a Flask application in Python. Should I go with the same choice? I don't know. Still, I think in this particular case, dedicated clusters sounds like an overkill. But to be honest, I think if this dedicated class, if they are deploying an application which is a web app plus a database, and maybe the database is managed using CRDs, my thinking is maybe I want a little bit more isolation this time. So we'll go with a dedicated control plane. Do I want dedicated node pools? Yes, I do. If you're deploying databases, I want to make sure that there is no noisy neighbor problem, right? So I want to make sure that I separate, I isolate the issue where one database could affect others, or one tenant could affect others. Maybe I can not use the sandbox runtime because I'm using a WAF in front of my apps. And I've got the choice, again, monitoring and logging. Should I go shared or dedicated? Maybe I go with shared ingress and shared logging, because I know that this app won't be, maybe they were going to be used internally. So, or I'm sure that there won't be a problem with the ingress if one of these is overloaded. Yeah, so I think those are like two examples. I think they tend to be, I think the examples I presented tend to be, not a real representation of what you will face in reality. In reality, you will not just have monitoring and logging and ingress. You might have more shared components that you need to account of. But at least I think this should give you an idea about how to approach the problem. So this is not meant to be like a definitive framework for evaluating what you should do, but it should give you just enough expertise to look at the problem and say, I know what to do next. So takeaways. So what we learned today. So I think it's important to tackle the problem to start with the requirements. So when you have a problem, when you want to do multi-tenancy, when you want to build a platform on Kubernetes, I think you should start by looking at what kind of isolation do I want? How much do I trust my users? And should I trust them? And then you look at, okay, what kind of options do I have to make my life easier? Right? Is the isolations pushing me to build more tools and to use more complicated tools? Or can I get away with something different? And how these choices are going to affect, my costs. And when we look at costs, we look at costs which are direct. So running one more pod or running one more cluster. And then we're also looking at indirect costs. So things such as, how many Prometheus do I need? How many ingresses do I need? And today we had a look at what I call Namespaces++, which is basically all sort of tools and software, which is basically creating multi-tenancy on Kubernetes based on namespaces, like capsule or hierarchical namespace controller. So these are like Namespaces++ because they are very lightweight. They've got some trade-off which are basically made of. They're designed to help teams which mostly trust each other share a common cluster. And I think that's a good choice to make. Then we had a look at how we can isolate it even further within a single cluster. And this is basically the positioning for vCluster. I think this is probably where you can get the most isolation in a single cluster. And then finally, we had this dedicated cluster. So this is a very, very much an extreme where we look at each team having their own dedicated cluster, and then the cost for managing something like this. Yeah, like I said, I think direct costs are one thing, but looking at these costs ballooning as soon as you add more stuff on top, then really opens your mind. Because if you think about it, when you run the cluster, you need to run extra kubelets and extra control planes, and yes, this cost adds up. But running one more Prometheus, one more open telemetry, Jaeger or Elk stack, yeah, that is really going to add up to the costs very, very, very quickly. Yeah, I think that was basically all I wanted to say today. So thank you very much for listening to this talk. I hope you enjoyed. I want to just say thank you for Loft for having me. Thank you very much. And yeah, that's it.
Awesome. Thank you so much. We've got Q&A and stuff now. We've got a bunch of questions already queued up. We can probably move on to that. You may go ahead and get started with it. Well, great presentation. Thank you so much. Like, that was very informative. And I think every time every time someone gets into Kubernetes, the first question is, do I share it with people? And then you get the first request from a developer, hey, can I get my own cluster because I don't want to overwrite this other person's cluster. And by the time you actually take a look, you've got 20 or 30 clusters running.
Yeah,
It's very
exactly.
expensive. What does this cost?
And then I think, to be honest, I think the one for me is like, when I started, it was like, okay, I can just use a namespace. And to be honest, I think next week we'll have Salman, and Salman will basically just dissect all of this.
Oh, awesome!
and look at how we're gonna, how isolation in the namespaces work and why it doesn't work. So I think, I think that is going to be interesting as well.
So we had a couple of questions. Everyone was kind of asking, will there be a recording? There will be a recording. And then we had another question. For the recording, there should be an email coming out probably in like a couple hours, something like that, saying where to go check out the recording. I think it'll be on our YouTube, but not 100% sure. Also, the question was, will the slides and all be available? Do you have somewhere that these slides are, or should they just look at the blog post maybe because that has some of the stuff in there?
I think I can make the slides available, but all of the slides, you might have noticed they're quite visual, so there is no notes or anything. So sometimes they make it's a little bit hard
that makes
to
sense.
sort of picture what I was saying at that time. So I think the recording will really help.
Yeah, so check out the recording in the blog post.
Yes.
All right, let's go. Let's go ahead to the questions real quick. So I'll start with the first question. So, is it possible to restrict access to a particular namespace? For example, I want users to access all namespaces except default.
I don't think you can say except. So you will have to say, I want to access to this, 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 and this.
And then just keep adding it as like you add more namespaces they want to have access to. So you're gonna have to automate that maybe, not just don't include X.
I think the one solution I've seen in this area, and I think this is the only one I've seen, but there might be others. This is just sort of something I'm sharing is that. So I've seen the Capsule project. So the Capsule project is one of these namespaces plus tools that lets you add more sort of higher level abstractions to manage your tenants, but still based on namespace. And they've got like a proxy which lets you sort of give access to particular namespaces to your tenants. So instead of going like, I think it works by connecting to to the API server and kubectl. I don't know how, but basically you can do kubectl get namespace, and you only see the namespaces you're allowed to see. So I think that's basically the closest you can do to what you describe.
Gotcha. All right, so let's see, next one.
Someone else is also suggesting Kyverno. Yeah, well done. Yeah, well, I think that's an option. Yeah, good.
All right,
good
so if
one.
you're posting the chat too, make sure you're doing it to everyone, because you're posting it to us, and we're getting the useful information. But I think some
yes,
others may be missing out on it.
I'm cheating. Thank you.
Let's go to the next one. So, what happens if you attempt to upgrade the tenant cluster control plane without disabling sync? If there's exists a depreciated APA resource on the tenant cluster. So I guess they're talking about like, what if you upgrade the tenant cluster and you use something like vCluster, or just
I think the sync. Yeah, I think the sync is vCluster. Mike, do you mind?
Yeah.
Do you mind taking this?
So if you upgrade the tenant cluster, that's a good question. So I don't know how it's going to reconcile that, right? Like if it's already existing, you upgrade everything, and now the API makes it invalid. How's it going to keep the spec up to date? I'm not 100% sure. I think that you might have issues because the API will have a different spec than maybe what you have, but hopefully that's only on bigger jumps, right? Like hopefully that's not going to be like you're just making like a huge upgrade from like a very old Kubernetes cluster to a new one, and you still have the same API resources. But to answer that without giving a real answer, maybe try it on a test cluster or something like that first, right? Like instead of doing production. You got something, Daniele?
Yeah, I was about to say, so we usually work with version resources. And when I say version resources, right, it's the name ingress v1, vb201. However, when you store these resources in etcd, they are not stored like that. They are basically stored with basically what we call just an ingress, just what Kubernetes thinks is an ingress. So as you upgrade that basically the control plane just upgrades that resource. And then when you request that resource, that's basically reserialized in v1 or vb201. So I think I'm not sure 100% sure how it works in vCluster, because I'm still trying to make sense of all of this syncing. But I suppose that if you are upgrading every time and these resources inside the control plane is upgraded as well, then there won't be a problem. Then we have a problem when things go out of sync, because you have something. Yeah.
Yeah.
Or, and then sometimes you have the problem where, you've got resources on in your Git repo, right? And it goes out of sync with control plane. So you upgrade the control plane. It's not able to accept v1 beta 1 anymore, but v1 beta 1 is something that you have in your Git repo. You try to apply, you see an error. That's what.
You might not notice anything until you try to recreate it or upgrade it or update it or do anything to it, because it's just going to save it. Okay.
Correct.
All right, so next one. Can we control individual elements if they can be synced versus managed outside of sync? Yeah, you can specify what you want to sync in vCluster. If we're talking about vCluster, you can specify what you want to sync. Like, say you don't want to sync ingress, you can turn that, you can just not enable it. Or if you do want to sync ingress, you can enable that to where it'll use the host cluster's ingress and other CRDs if you want to sync those. So you can control what syncs and what doesn't. In terms of like, do you want to give access to what's running on the base cluster, or do you want them to install their own CRDs? Stuff like that.
And I think that's actually the interesting part about the vCluster, is that you've got all these dials, right? You can tune, and that's basically when you can shift your isolation, to be harder or to be weaker. And I think this is where I think, of all the options, this gives you I think it's a more flexible, because it gives you this ability to tune how you want. At least this is what I found. I think if I want lighter, then definitely something like, capsules or hierarchical namespaces. But this one basically, at least in my mind, it covers like a broader spectrum.
Yeah. All right, next question, kind of similar. How are CRDs handled with the sync? So you as the administrator are going to decide what syncs, right? So you can sync and give access to CRDs on the host cluster up to the vCluster if you want to. That's going to take some configuration. Or there's some built-ins too that you can just sync, like ingress and stuff. But if you're talking about like or talking about CRDs outside of just the basic stuff, including Kubernetes, like cross-plane or getting into that, it's going to take a little bit of configuration if you want to share that up. Otherwise, your users can install CRDs into their own virtual cluster because they have their own API that's separate from the base cluster API. So if they want to use a different version, or if they want to use certain CRDs that aren't available on the host cluster, they can create it there. So how does it sync? You just install it into the vCluster, and it'll sync down. Like it'll figure out how to configure it on the Kubernetes cluster if it can reconcile it. As long as the versions aren't way too far apart, I guess, right? Like we were talking about earlier. Do you have anything to add, Daniele? Like I'm just tech marketing, so I'm answering as much as I can. If I can't answer your question, like I said, join Slack, and then some of our developers and stuff and super technical people will be able to answer a little bit more than I can too. But I'm gonna try to answer as many as I can.
I think, Mike, before people are leaving, we should just mention that this is the first installation of the series.
Yes.
And next one is coming next week with Salmon. And I think if you haven't signed up, please do. And the next one, I think first to say, it's very much more foundational on namespaces. So you will see some interesting stuff on how Kubernetes works under the hood.
So come back next time too. Yeah, this is just kind of the intro to what's going on, and then you're going to get a lot more deeper stuff next time. All right, so let me see, answer that one. Let's go to the next one. What about global resources? A lot of questions about CRDs. What about global resources like CRDs? If you sync them in the same way, we don't have real isolation. Am I wrong? Well, so like I said, you can install CRDs into the virtual cluster that are separate from the host cluster, or you can install them in the host cluster and share them up. So it just depends on your configuration about how isolated you want everything, and how much permissions you want to give to your users to be able to install whatever they want in their cluster, right? Because everyone's going to want to try a different version of something, or they're going to try something new, and you don't want to have that on the base cluster everywhere if you can handle it, because then you're going to have to manage it instead of them.
Yeah, I think what's great is that all of these things with something like an isolated control plane is basically they are cheap to create and cheap to destroy, right? So we had a look at costs, but I think the only way to have like a dedicated cluster, which is not a full cluster, is basically to create a control plane. And I think this is the easiest option, right? You just you test the CRD and you tear it down. And it's a very cheap operation. And I think that's basically where you see the ease of, we talked about these 3 axes, isolation, ease of management, and cost. And then ease of management, you get it is easier to spin up clusters with something like vCluster than fully dedicated clusters.
You're talking about like speed too, like it's a lot faster.
Yeah,
and it costs a lot less.
Well, I think speed, there are some providers that tend to focus on that, other tooling, but I think just the simplicity of just going there and doing, okay, let's create a new control plane is just a pod. I think that's I think it's unbeatable.
Gotcha. All right, so let's go to the next one. So how does this differ if you have multiple clusters and different teams and deploy on those clusters while controlling on Argo CD? So yeah, Argo CD, great use case. You would just create the virtual cluster, and then you would, so I'm going to answer the vCluster. They might be just talking about in general, like what would you do with multi-tenancy? But like with vCluster, you can just get the kube config for the virtual cluster, add it to Argo CD, and then you would just treat it like a regular Kubernetes cluster. So you could deploy with Helm on there. You could even create virtual clusters through Argo CD using the Helm chart. So you can use but the vCluster is going to make it easier to where you can just stand up a cluster quickly, deploy something, test it, and then just delete it quickly too. So you don't have to worry about the spin up time. Daniele, I don't know if you have something to add about just in general, like what about using Argo?
I think, to be honest, I presented at the end Kamada as a way to sort of control all of these other clusters, but I think Argo is also one of these other tools that let you sort of reach that level of automation. But yeah, I think, and then what I was surprised to see is that, if I look at Argo, Argo also integrates very well with the Namespaces ++ solutions, as well as vCluster. So it's a very versatile tool when it comes to multi-tenancy. I think my worry is not about Argo, as it would be like my choice for deploying and creating these tenants, rather than what does this cluster look like? Like what is the multi-tenancy sort of configuration for this cluster? So I think that would be my first concern. I think Argo is sort of just a tick box. Yes, that.
Yeah. But in general, if you're using anything like Argo or something like that, yes, it would work with vCluster to where you're just creating quick ephemeral clusters that spin up in like a minute, and then you can do whatever you need and then just delete them. But there are ways to hook it into there too. Let's go to the next one. So how does vCluster work with managed Kubernetes solutions and their integrations? So AWS, if you want to create IAM roles bound to the EKS cluster, OIDC provider, it's a long one, and specific services for AWS access.
It's a full project.
Possible for vCluster. Yeah. So is it still possible for vCluster managed clusters that don't have an AWS OIDC provider? So like we've got a blog post too talking about how you set up storage and everything. So you need to set up different roles and access for this for like storage so that you can expose Amazon storage like on EKS or something like that. So you're still gonna have to create some of these things for the roles and bind them. vCluster is like a level up, and then I've only done the very basic stuff on that. So like for a more detailed answer on this, we might have to go to Slack. But I don't know if you've messed with vCluster on EKS at all, Daniele, if you have any.
No, but I study the architecture quite a lot, and I think there's like vCluster's got some design principles on how they develop these controllers and control planes. And the basic idea is that everything is as simple as creating just a stateful set, right? So this is why I think deploying vCluster is so versatile, because it doesn't matter what client cluster you have. You can just deploy it as a simple stateful set, and then from there you just create these nested clusters. I think what becomes a little bit more complex is the syncing mechanism, and that's basically where what Mike's is saying about workload identities and integration with the EKS. This is where it becomes a little bit more complex. But if you want just the vanilla stuff, just deploying these simple stateful sets, there will be enough to create these isolated control planes. For the workload identity, I think that's something that you would need to go and check the documentation or someone more expert than me.
All right, cool. So I got information too, like the next two parts, March 7th, March 14th. So I'll try to get that posted in the chat too, so that we have that information. All right, let's move on to the next one. We got a bunch of questions. Isolated control plane can work with AWS EKS. So I'll say vCluster, yes, but you were talking about other options. Have you looked at the other options with?
So isolated control planes, I think. So there is vCluster, and then there is what I think it's called vCluster as well. So a project from the official Kubernetes SIG. Which overlaps in name as well as functionality, but I don't know how well it's maintained. But apart from that, I wasn't able to find anything which is exact replication of vCluster. So I think
Yeah.
isolated control plane as pods, I think the only one doing it, in my research was vCluster. I find other project which can do control plane as a service. So you basically, you have dedicated control plane as pods, but they cannot be used inside managed services. So solutions like Hypershift or Kamaji, those can basically create these, sort of same feeling as vCluster, but they sort of require a different setup. That's for sure.
Awesome. And then on our side too, on Loft, vCluster Pro will give you access to another kind of isolated control plane where you can deploy a control plane, and then you could tell it which clusters to deploy the workloads and stuff like that too. So you got vCluster open source and then vCluster Pro, which is the enterprise version that gives you another step up on isolated control plane where you're not running virtual cluster stuff on the worker nodes. You're just running the work loads. All right. So next question, same person. Any actual use case for Karmada? Do you have any blog posts or anything that you want to share on that you've worked with?
So I presented Karmada and multiple, in multi-region clusters last year. And then what I did, I basically deployed 3 clusters in 3 different regions, and I installed Istio on top. And then I shifted traffic from one region to the other. So you could basically request for an applications in London, and you will get a response from Singapore or San Francisco. And you could also write policies where you basically just prefer the local traffic and then move everything else. So I think I can I can find where the link is and share it. But I tried. I think Karmada is somehow in the same league as Argo CD, and my thinking is, should I use Argo CD? Should I use Karmada? I don't know. At the time, I was like more interested to explore this different tool, but I think everything you do with Karmada, I think you can also do with Argo CD. But that's what I would use Karmada for, only for that.
Awesome. Looks like your answer was good. So we got a thanks. All right. So let's go to the next one. How does vCluster work with service meshes like Istio? Do I need to install it separately in each isolated environment inside in the same cluster, or is there a way to have one installation in all? So this is like the question, right? Like, do I install Istio in my virtual vCluster, or do I install it on the base cluster and do all that configuration? And I've seen both, right? Like, I think that,
oh wow.
But like, for the most part, like I asked this question on one of our previous vCluster office hours, and the answer is like it depends, right? Like it depends on what you want to do. I would have thought that I would just install Istio on the base cluster and do.
Yeah, I would have thought as well.
Right, but I don't know. It depends on what your use case is. I would say on the base cluster, but I think we also have some information about how to install it into vCluster if you want. But
oh wow,
I could be wrong.
For the most I can only imagine setting policies.
Yeah, I don't know. I don't honestly know how. Inside of the vCluster, like I've never tried to do it inside the vCluster. I always do everything on the base cluster, so I don't know how that works. Like it's beyond me. So we have engineers that can answer some of those questions. I've always done on the base cluster. Let's answer another one. Does this apply to OpenShift or Kubernetes platforms? I think this was asked when you were talking about, or are you just asking, I don't know if this is in general. If this is just in general about multi-cluster stuff, yeah, you can do the stuff on OpenShift and other Kubernetes platforms, like I said, EKS and stuff like that. As long as it's Kubernetes and you can run a pod, you can pretty much run vCluster unless there's like some crazy thing excluding the ability to run stateful sets or something, anything like that, right? Like you should be able to run this. I don't know if you have feedback, let me know, Daniel, or I'll keep going because there's like another 20 questions. All right, so we shared about teams. My question is related to different environments. Let's say dev stage, test, prod clusters. How should we approach that? If we're also on AWS cloud with first and EKS, second use case, let's say KOps or Kubernetes. So I'll let you answer this first. So what do you think for like different environments for dev, test stage, and prod? Like what are you using?
Yeah, I think that's a good question because I see multi-tenancy as a way to separate teams, to separate what they do or separate projects. But I can also see, I also see that some of the clients we work with, they use these separate clusters for lower environments, right? So we're talking about dev, staging, QA. And, one of the things, at least in my mind, is when I try to figure out how many environments, how many teams is, the cost of managing all of those environments. So I think what I've seen most common is companies doing like lower environments on a single cluster and just sharing it, and then having like production on a separate cluster. And when they have this, single cluster, then they find more, way to sort of slicing and dicing the cluster for multiple tenants. So, a solution like vCluster, for example, or a solution with namespaces, depending on the isolation appetite you've got, would be an option to create lower environments for different teams. I think that could be an option. But again, it goes back to, okay, what is my appetite for managing a lot of clusters and reusing resources? What is going to be the costs? How much effort? So it's always, a trade-off. And something that you need to keep in mind, something to give and something to take. So yeah, it depends.
Yeah, I'll say the cost. The cost is probably the most thing that depends. Well, cost and the scale are probably the
But
heaviest
across the
things.
scale,
like,
yeah.
yeah, it's like if you're just starting out and you've got like a couple of things running in prod and it doesn't matter that you've got other stuff running, like, and you can share the cluster. Yeah, run it all in the same spot. Like you're saying, like maybe split off dev test and stuff, and maybe have like dev test and stage in one cluster, and then you can use vCluster to do all of those in the same thing. And then maybe your prod's moved off somewhere else. It's a little bit more important to you, but you can use vCluster for each of these things that you're talking about. We're talking about like splitting it up. So there are people using vCluster for dev, stage, test, and there are people using it for prod too. We have there's actually a video from right before KubeCon that's talking about someone using vCluster in production. CoreWeave, they're using it for GPU access and stuff like that too, and that's vCluster Pro. So you can check that out. All right, answered that one. Let's go. Is it possible to have different customers from different organizations share a cluster with full isolation? Do you think vCluster may be the solution for this? So since I'm answering the first, let me let you answer, and then I'll give the vCluster spin, right? Like, so you can talk about like everything. Yeah.
I don't know. It depends how much you trust those users. I think it all comes down to, what kind of trade-offs you're willing to accept. And then sometimes you've got like, you might choose, let's say that your concern is that someone is going to deploy an application which is going to, I don't know, it's going to have, could escape the node. I don't know. It's going to escape the container. Then maybe the mitigation for that is actually use a sandboxed runtime, such as gvisor or something like Kata containers. So that could mitigate that part. So maybe you're concerned that the application that you deploy are very I/O intensive, and like Kafka, for example, and you don't want that to be sort of running in the same node as some other I/O intensive apps, like databases, for example. And a good option for that would be just having different node pools and using non-affinity and taint tolerations. And maybe you have all of these problems at once, right? And you can stack the solution one on top of each other until you get the sort of isolation that you really want. But of course, the more things you stack on top of each other, the more, the complexity and the costs will go up as well. So I think it's always, going back to what is actually your requirement? What kind of problem are you trying to solve? Do I actually trust these users? What kind of things could go wrong? So you sort of have a profile for sort of risks that you're accepting. And then against these risks, then you can plan for the right level of multi-tenancy, which is going to give you the right level of isolation and security. At least this is how I would approach the problem.
So like the answer basically is technically yes, you can do this. You can use no groups and stuff like that. The stipulation is that your security, you've got locked down and you understand like how you're going to secure this and make sure that like nothing escapes. But in terms of like data privacy and stuff like that, or making sure that people have their own clusters versus or their own actual physical nodes or something like that versus having a shared environment, yes, you can use node groups and you can specify, what vCluster is allowed to see and allowed to access and where certain customers are allowed to deploy stuff. And there are people using vCluster in production to do this thing that you're asking, which is like a multiple customer SaaS option, and they need to install this software as a service in a certain location that only that customer has access to. So it is possible technically. It might take some work on your side to figure out security, and then also after you get it set up and installed, maybe do like a dry run and make sure that it is secure and you don't run into some of the other issues. All right, so next one. What do you recommend for multiple tools to manage a Kubernetes cluster, or have a dedicated cluster for each team? Okay, so All right, so yeah, I guess they're saying, what do you recommend between the two that you're talking about, having a single cluster or dedicated cluster for each team? But instead of being each user, we're talking about team based.
If if possible, I like to keep things as simple as possible. So my first choice would be, okay, can I solve this with namespaces? No, okay. Can I solve this problem with namespaces plus plus? So, this capsule or hierarchical namespace controller. No, okay, then I move up vCluster, then I move up dedicated clusters. So I think if I can, I just stay with the lowest complexity as possible, because that is going to give me also the lowest costs. But that's, of course, not always possible. So that's why I would basically just gradually increment and move on the ladder. At least that's what I would do.
It's a loaded question too, because what if these teams are, one team's in Europe and one team's in the US? Then yeah, you might have to do something like give each one their own like dedicated cluster for data privacy rules.
Yeah.
Right? Like,
yeah, it could be. It could be. Maybe I don't have a choice. Maybe I don't have a choice, and I can just have. I must have like one dedicated cluster per region, and that's it.
We got to reply to your thing too. Yeah, they like the idea of start at the easiest and then kind of increment up to see what kind of stuff you need to use. You need to do you have a presentation about just that, like how to think about that from the beginning when you're setting up Kubernetes? Like, what are your kind of what you showed us here, but do you have one that's just like completely dedicated to every single time I start up a Kubernetes cluster? What are the exact steps? I saw you had the software too that you're talking about, but like, is there someone they can watch more information about that? Like beyond this, like, do you have like, or do you, if someone comes and asks you, do you have anything else beyond what you've presented here that you think about? Because the idea of starting at the easiest and then moving up namespace plus and beyond that, like, where do you go?
I don't, to be honest, I don't know. I don't think I've got, I tend to just focus on, on what I've got at the hand and just build on top. So I don't think I've got any
Maybe ask this abstract question and see if you have an answer. I'm sorry. All right, let's move to the next question. What do you think about software like Gardener or Classics?
So I haven't used Gardener, and I'm not familiar with it, so I cannot comment on Classics. So they've got two products, Kamaji and Capsule. I think Capsule is part of this Namespaces plus product. So this product that augment namespaces, and I think it's actually part of this lightweight tool. So if you're looking for light multi-tenancy, so soft multi-tenancy, I think it's actually a valid product. And maybe, this is just personal preference, but maybe between the hierarchical namespace controller and Capsule, I would actually pick Capsule. And I explained, I explained this RBAC sort of proxy, which lists all the namespaces. So they sort of thought about the experience, so they understand what their users need. And I think the hierarchical controller still is doing it, but not at the same scale. So I think I will probably look at that. And then they've got another product called Kamaji, which is control plane as a service, which is also part of what vCluster Pro does. And I think for that one is a little bit different. I think the use case is much narrower. So I think only few, I would imagine that not many companies can attempt on something like that, at least in my experience, at least based on what I understood about the project.
Awesome. Yeah, I haven't used either, so I don't know. I can't add anything, but I'll go to the next one. So I had a very basic question. What is vCluster? Is it industry approved or is it something by Loft? So it's by Loft. We have other projects that are actually part of the CNCF dev space. But
I just want to add, Mike, which I think is important, at least for me, is that all of the tools that I presented are open source. So you do look at a hierarchical namespace controller, you look at vCluster, you look at Comada, you can just download GitHub and you can get going. So while, yes, it is a Loft product, Loft offers a premium version, then you can still just download it and use it. There is nothing stopping you from doing that.
I guess let me differentiate between that. Yeah, so we have vCluster open source and then vCluster Pro. So the open source one is actually something that's been presented at many KubeCons. Like there are people out there that are using this in addition to other industry approved, or what you want to call like stuff that's in the CNCF or in the CI/CD or something like, or the CI/CD group or whatever. The other split off one that's got like Argo or some other stuff. Anyways, yes, kind of. I mean, it's something by Loft. It's open source. You can use it. There are people using it in the CNCF. Yeah, I'd say it's industry approved. I mean, until until there's something that's very similar, which there's not. There's some similar things, but I think a lot of the presentations and stuff at KubeCon are about this. All right, let's see. How do we subscribe for the next presentation? So I think there were links in the chat, and if you go to one of those links for the series, you should be able to sign up. So we got Workshop Series Part 2 on the 7th, and then on the 14th. All right, and then I think maybe the follow-up email too may have information about the next ones that are coming out. All right, should you define resource quotas per namespace in a multi-tenant environment where each tenant is on its own namespace? If so, what is the best approach to define quotas? So I'll go to you, Daniel, and then I'll start doing the first one again next time.
So which one I answer? The quotas?
Yeah, the quotas. Yeah, so I already did the presentation one. So
okay. Quota.
Yeah.
Okay. So generally with quotas, I think the way I've seen quotas and the way I think quotas should be done, and this is not saying that this is the exact way, you probably can take this and change it, or you have different ideas. But quotas are generally linked to costs, right? So when you manage a multi-tenant cluster, then somehow you need to you need to divide these costs and assign them to teams, and team will have some budgeting, for how many resources they can run. So we're talking about real money, right? At the end of the day, running these clusters and nodes isn't cheap, right? And we need to find a way to actually divide the usage and make sure that teams are paying proportionally, right, based on the usage that they have. I think the idea is that if you're gonna charge back your users for the resources they're gonna use, then the simplest thing you can do is to actually define, a small, medium, large quotas, right? Assign a price to it, a price that is going to be paid by the team, and then just give these quotas to the teams. So in such a way that the quota is linked to a monetary value, and teams can make it bigger, but you also need to pay more. So there is an incentive to be efficient. That's basically how I would link money to quotas, at least in my experience.
There's tools out there too that are getting better with chargeback, like kube costs and all that too, right? Like say if you're in a government contract and you have to know exactly how much you're paying for everything because you have to do it at the end of the month for like your internal research and development or something. You have kube costs, which is going to help you a little bit with actual usage. But yeah, I like the idea. I like that idea of actually just having small, medium, large, because then you're not monitoring it all the time and having to like get all these metrics, and then you just say, okay, this is what
much easier.
Pay. And then it's on them. If they're like, hey, we're not even using medium anymore, we're just using small, let's go ahead and switch over. Then you don't have to worry about anything on your team.
Yeah.
Awesome. Okay, and then so how do we just establish connectivity between vCluster and the Kubernetes control plane? So I'm not sure on the question for that. Like the syncer might be what you're thinking of, is like how does vCluster get a resource and actually create it on the base cluster? So it's going to have the syncer. So you're going to create something in vCluster, and it's going to actually still tell the base cluster, hey, create this thing for me. And then you're still using the same reconciliation loop and the controllers of the base cluster. I don't know if you have anything to add, Daniele. I might move on to the next one. But I think that's what they're talking about, the connectivity between the two. Oh, let me go one more time. Let's talk about ingress. If you're talking about how do I access my vCluster in, the Kubernetes, I don't think so because they said the control plane, but also ingress, you can access vCluster through an ingress resource because it's just another thing that lives in Kubernetes. All right, how to isolate multiple tenants in the same cluster. Yeah, that's kind of what we're presenting on, or Daniele was presenting on. You could use something like vCluster or some of the other options. You can isolate them based on nodes, or you can just give them basic isolation by namespace. So I guess basically the presentation was kind of about that. So hopefully, maybe go back and rewatch the presentation. Unless you have something you want to add.
We're gonna share the recording anyway. So
yeah, we'll share the recording so you can rewatch it. All right. So which option is best for performance matters? Having a shared ingress or that's a good one. Having a shared ingress or dedicated ingress per team when using a load balancer in front of ingress like HA proxy. So what's best for performance?
That's really good question. For performance, that will basically be dedicated clusters, but dedicated ingress controllers. But cost. It's going to be interesting to say the least.
So the idea being that like you got load balancers in front of each of these, right? Like unless you're managing your own load balancer, for the most part, you're going to buy a load balancer and you're going to have a public IP address, and that's going to be in front of every single ingress controller, right?
I mean, that's performance, but yeah, the cost is going to be problematic. So
yes.
And to be honest, sometimes you have to bite the bullet. There's nothing else you can do.
Yeah.
It's just the way it is.
You say you're not going to one-off, but then you'll one-off 50 times, and then the one-off becomes the norm. So yeah, so I guess basic answer is depends on what you pay for. The performance is going to be dedicated, but that's going to come with the cost of a load balancer per ingress and having multiple ingress resources, ingress controllers that are running in your cluster. So now you're paying for that workload too, instead of just having a single. All right, so let's go. Can you give an idea? Oh, can you give an idea at what scale would Karmada potentially make sense?
To be honest, it's a good question. I asked myself the same question, and the answer is I really don't know. I really don't know. And the reason is I think I would use Kamada when I'm forced to use separate clusters. And I'm forced to use separate clusters. And I think the reason why I would use separate clusters is because one, regulatory reasons, right? And two is that, you know, some sort of, you know, data protection. So it goes back to like requirements that are coming from the top that I'm not able to change, right? I'm not able to work around. So that would be like my thinking.
All right. And I haven't used it, so I'm not sure. All right. So the next question is: does this use case apply to OpenShift, Tanzu, and Rancher? And I would say yes. Right. OpenShift, I don't know how the licensing is now, so don't quote me on this. The last time I touched OpenShift, which is like 5 years ago, it was like I think it was like a license per node. So if you can reduce the amount of nodes, or probably and cluster, right? So you've got the cluster and the node. So if you can reduce how many you actually need to deploy and how many nodes you need to deploy, I mean, nodes being workload based, that's a little bit different. But if you can reduce the amount of OpenShift instances that you need to deploy and then share that among many different teams, yes, you can do that, right? You're going to give them access to it over like kubectl. I don't know how the OC or OpenShift command line stuff integrates with that. You're just probably going to interact with it like it's a Kubernetes cluster. Maybe you don't get all of the stuff that's above. Tanzu and then Rancher, same thing. Rancher, you're just deploying like the cluster, and then you would install vCluster on top of the cluster itself. Like it's a Helm install, so it's like you're deploying an application into Kubernetes, but then you just give your users access to that instead. I think that kind of answers it. I don't know if you have. All right, let's go to the next one. Is there a Slack channel? Can we get a link for the same? Yeah, so Slack channel has been posted in chat, slack.loft.sh. You can join there and then go to the vCluster channel and ask questions, or I mean, there's a bunch of other channels in the street. All right, so next question. Hi, all. Can we have specific CNIs like Cilium on the tenant cluster running in a hub of clusters of vCluster? So you can use Cilium. I haven't. So this might be a better question for you. I haven't installed Cilium and used it with vCluster, right? So when you get to networking and stuff like that too, it gets a little bit interesting. Believe it works. I can't say that it works as in I've tested it, but I believe there are people that are using it and it should be fine. Here's your chance.
Yeah, I think Cilium is installed in the node, right? So it can only run inside the host cluster, it cannot run inside the tenant. Okay, so I think what you might be interested in is maybe running the network policies, and I think those can be created inside the tenant control plane. But then there is something called the Cilium network policies, which are a global network policy, and that's a CRD. And I don't know how that would work because you need to install the CRD in the tenant, but you need to install Cilium in the host.
Yeah.
So I don't know how the installation will work. And then you need to basically configure a vCluster to copy that particular CRD across. That will be the end-to-end solution.
So as a tenant, no, probably not that easy. As an admin, there's a lot of configuration, right? Like we've had this question before. And it's like, I don't know, I haven't installed it. Like you would use something like a generic CRD syncer to share the resources up if you needed to, but then the administrator's still installing all the stuff in the base cluster, especially when it goes a little bit deeper than ingress or something like that. All right, let's see. Let's see. What do you think about Site 24x7? I haven't heard of that one. Yeah, I'm not sure. Okay, so we'll say we enter these live. I'm not positive about that. If you have more to expand on that, maybe put it in chat or ask a question on expanding a little more. Okay, question around application performance. So I generally understand that running an application in Kubernetes has some level of performance degradation when compared to running on bare metal. Correct me if I'm wrong. Enforcing vCluster, would it add another layer of performance degradation as it's running another kube inside kube? If I understand it correctly, does it have a performance degradation? So I'll answer it first, and then I'll send it over to you. This is like, it's vCluster's abstraction. It's not virtualization really. It's kind of abstracting. Your stuff's still running in the base cluster. The performance degradation that you would actually see would only be like the pod that it takes to run vCluster. So the vCluster resources that are running core DNS and stuff like that. Then the application itself is actually running on the base cluster. When I create it, you're going to be able to see as the admin that it's running on the base cluster, and then other resources like Ingress and stuff like that I create for the most part are running on the base cluster. So we're just using Kubernetes, adding another API, and then just deploying stuff still on the base cluster. So there's not a level up. It's just you're adding a couple of pods for vCluster on top of what you would normally be running. So the workload stuff, maybe if you've got like 100 vClusters on a single node, then you got to be thinking about like, okay, I'm running like 100 more pods or something like that than I would be running if I was just running on the base cluster. Daniele, I don't know if you have anything.
That's a really good answer. That's a really good answer. Yes, exactly.
I'll say upsell on my side. So like something like vCluster Pro takes the vCluster workloads that are running on the worker nodes, and it removes those, and you basically have a control plane outside of the worker nodes. And what it does is it'll run the workloads there instead. So then you have even less pods that are running for vCluster on the node. So really important if you're doing stuff like GPUs or something like that, and you want to use every bit that you can use, and maybe you're running at 80% plus optimization. I don't know. All right, so let's go to the next one. So we have 33 EKS clusters across the globe for different entities. Can Karmada manage them better than Argo, like upgrade and everything?
If you have Argo, just stick with Argo. Yeah, I think there is no. I think they are the same. I think Argo will probably be more feature rich, so we'll probably look into Argo. But I think Karmada and Argo, for what I'm using them for, there is a fair amount of overlap.
Okay, awesome. And it looks like this is our last question for now, unless someone queues up another one. So, this is just someone that's just saying they need to run. Okay. All right. So if you have any other questions, like post them up. Like I'll say some information about like vCluster and vCluster Pro. vCluster.com if you want to check out vCluster. A lot of stuff in the open source that you can do. There's a lot of documentation and different things out there and use cases using vCluster open source. Recently, we launched vCluster Pro. It's the enterprise version. It's got a UI. It's got a bunch of other stuff built on it, like embedded etcd and other cool features that make it a little bit easier to get to day one, self-service, integration with Argo CD to where when you create a vCluster, it'll automatically get added to Argo. But if you're interested in vCluster Pro and you want to see just a demo just to see what it is, or if you're interested in vCluster, head over to the Slack, ask on there, go to vCluster.pro if you want to sign up for a demo and see what it looks like. Plus, we also have videos on our YouTube channel. I believe that this video here is going to get uploaded to our YouTube channel, so you'll be able to check out some of the vCluster Pro stuff there as well. But I think we're good on questions. Let me look in chat just to make sure that something didn't like get added over there. A lot of people having to drop off. They'll check it out later. Thanks for the presentation and all that. I'll say, Daniele, thank you so much for the presentation.
Thank you for having me.
Very informative. Can't wait till the next one too. I think is the next one
next week.
More information next week. All right, and then there's one following up after that.
Yes.
All right, cool. I don't think we have anything else. Do you have anything you want to say before I guess we head out, or?
No, I think that's pretty much it. I very much enjoyed. I spent a fair amount of time researching, and I hope it was useful. That's it.
Awesome. I think it was. We got so many questions, so I think people were engaged. Yeah. Thanks so much for watching. Like I said, you can watch this again later, and then join us for the next one too. I think the next one's gonna go a little bit deeper into some of the questions we got here. Yes. Maybe I answered well. I mean, some of them. So yeah, if you have more questions beyond what I answered, or you want a little bit more information on it, let us know. But thank you everyone for joining. And
thank you.
I think we're good.